Welcome to 12.7. 12.7 focuses on conditional probability. In general, if the probability of event 2 occurring, given that an event 1 has occurred or will happen, is called a conditional probability. Okay, so for example, you could say something like, what is the probability of selecting a red ball out of a bag given that you've already selected 10 red balls out of the bag? So that, if usually the key word is given, if you ever hear the word given, you usually know that you are dealing with a conditional probability. So you can use a formula for this. You do not have to use a formula for this. And in this first example, we won't use a formula. A single card is selected from a deck of cards. Determine the probability it is a club, given that it is black. Okay, so you have a given event. You know that the card definitely is going to be black. Well, there's 52 cards in a deck. And if you eliminate that down to only the black cards, that means you only have 26 cards to look at. So your total possible events are 26. You want a club out of that. So half of the black cards are clubs. So you know that 13 of the 26 black cards are clubs. So the probability of selecting a club from a stack of black cards is 1/2. The way they'll write that is they'll put the probability of club given that the card is black. Okay. Some people would prefer to use a formula rather than try to eliminate the possibilities on their own. And so if you would like to do that, the formula is not terrible. If you are trying to calculate the probability that event 2 happens, given that event 1 has already occurred, what you need to do is you first need to find the number of items of event 1 and event 2 simultaneously occurring and divide that by the total number of event 1 items. That's your formula. So sometimes instead of the and symbol, they'll use the intersection symbol. That means the same thing as and. Let's look at this example. 250 patients who had knee surgery, hip, or heart surgery were asked whether they were satisfied, dissatisfied, or neutral regarding the results of their surgery. The responses are given in the table on the next slide. So when you look at this table, the first row has knee surgery. 70 were satisfied, 25 were dissatisfied, out of a total of 95 knee surgery people. In the hip surgery category, 90 were satisfied, 15 were dissatisfied, and there's a total of 150 hip surgery patients. In the heart category, 45 were satisfied, 5 were dissatisfied. There was a total of 50 heart patients. And then if you look down at the bottom, 205 is the total number of satisfied clients. 45 is the total number of dissatisfied clients, and 250 is the total number of clients in general. So let's answer the question. If one person from the 250 patients surveyed is selected at random, determine the probability that the person, A, was very satisfied with the results of the surgery. Okay, so we had 250 people total, so that is your denominator. And we want to know the people that were satisfied. So the number of people that were satisfied was 205 out of 250. And then remember, you're always supposed to reduce your fractions. So these are both divisible by 5. So if you divide the numerator and the denominator by 5, you will get that 41 out of 50 patients was actually satisfied with their surgery. B, what's the probability that a random person selected was satisfied with the results of the surgery given that the person had knee surgery? Okay, so they said given. That means they want you to eliminate all of the hip patients and all of the heart patients and to focus solely on the knee patients. So there was a total of 95 knee patients. Of the 95 that were in surgery, there was 70 that were satisfied. And then again, you can reduce that by dividing each one by 5. The proportion of knee patients that were satisfied was 14 out of 19. What is the probability that a randomly selected person was dissatisfied with the results of the surgery, given that the person had hip surgery? So now, since we're talking about hip surgery, we eliminate the knee patients and we eliminate the heart patients and focus solely on hip patients. There was a total of 105 hip patients. Of the 105 hip patients, 15 were dissatisfied. And then, of course, you're going to reduce your fraction, which will reduce to 1/7. Choosing a randomly selected person, what is the probability that they had heart surgery, given that the person was dissatisfied with the results of the surgery? So this time, the given item is that they're dissatisfied. So that means you need to disregard the satisfied people, and you need to focus solely on the dissatisfied column. There was a total number of 45 people that were dissatisfied. Of those 45 people, how many of them had heart surgery? 5. So that means 1 out of 9 dissatisfied customers were heart surgery customers.